Hello, hello, hello. So for today's stream, I am going to be re-delivering this session that I gave at SIGCSE. SIGCSE is the biggest computer science education conference. It happens each year. It stands for Special Interest Group in Computer Science Education. I went there this year with Microsoft, and I had a sponsored session, which means we did pay to give it, about teaching modern web development Python. Now, the reason that I suggested this session is because in the past I've been to SIGCSE as just an attendee, just as a someone who is was a full stack web developer, and we often had these birds of a feather sessions, which is where you get together with like-minded folks and talk about some topic you're all interested in. And we always had one about web development. And in those sessions, it always felt like there were so many questions about what should people be teaching in their web development classes, because it's really hard when you're a university lecturer to keep up to date with what are the new current ways that people are doing web development, because web development changes so fast. So my goal in this session was to, share with teachers and lecturers and even students and TAs my thoughts on the components that I would teach if I was, teaching modern web development with Python in probably a university or advanced high school setting. So there you go. So this is about teaching, but it's also about learning. So if you are someone who is, learning Python now and you're thinking of using Python to do backend web development, then this can also give you an idea for what sort of things you might want to be looking into and learning. So I am a Python Cloud Advocate at Microsoft. If you haven't met me before, hopefully you have, since this is my channel. And before that, I was actually a university lecturer at UC Berkeley for a few years, teaching Python and also web development. And before that, I was also a full stack engineer at Coursera, where we did Python and JavaScript. I created a lot of the computer programming courses at Khan Academy, where I taught the front end as well, the HTML and JavaScript, and I was in developer relations at Google. So I've always had a career that mixed teaching and coding, and that's why I always find it really interesting to overlap between how we code and how we teach what we code. And hello to those of you watching. Hello, Lokesh. Thanks for watching. All right. So what I'm going to talk about, and I'm going to talk about these things fairly quickly, but we're going to have follow-up workshops about a lot of these topics. So today is going to be a whirlwind because I'm going to be talking about lots of different things and not going in depth because there's just not enough time. But don't worry, because I've scheduled all these follow-up workshops that dive deep into a lot of these things. So we're going to be talking about dev environments, web frameworks, databases, containers, Docker, developer tools, Copilot, testing, and deployment to the cloud, specifically Azure. So first step is choosing a language, right? When we are developing a web app, we need to pick both our front end stack and our back end stack. Now, for the front end, ultimately front ends are rendered in typically browsers. And if it's rendered in a browser, your front end is going to be HTML, CSS, and JavaScript, at least eventually. Now, you could generate that HTML, CSS, and JavaScript, and that's what many people do these days, especially when they have really highly interactive apps. So you could use a framework like React or Vue or Svelte or Lit or just web components, which are part of the browser spec now, and use all those in order to make your highly interactive pages. But ultimately, you are just working with HTML, CSS, and JavaScript. You could have clients that are mobile clients. In that case, you'd be doing native development. But most of the time, we're talking about doing websites. Another option is use something like HTMX, which would be really trying to do low amount of JavaScript and doing lots of kind of server-side scripting as well. So we're not going to really talk about the front end today because I really want to focus on the back end. But it definitely is a big decision point as to what front end you use. React is somewhat the default now, but it is a very heavy default to go with. So, when I'm teaching front end, I'll always start with, vanilla JavaScript, which is HTML, CSS, and just the JavaScript that the browser supports, right? And then, it's only when you get to something really complex and you start talking about you actually using a framework. For the backend, you can pick any language that can act as a server, which really ultimately could be just any language. But the popular ones are Python is really, really popular. Node.js is very popular since then you have both JavaScript on the front end and the back end. And I've used that a little bit as well. Java is fairly popular. C# is fairly popular, especially within Microsoft developers. Go is increasingly popular if you have like a highly scalable website. So Khan Academy actually recently ported to Go, and I was on the team helping to port it. PHP is still pretty popular. That's what I used back in the day. Ruby on Rails, very popular. And then maybe a few people using Rust, but once again, only for like high performance. So we're obviously going to be looking at Python today, since that's the focus of how do we teach with Python as the backend. So why use Python? Well, I think it's a pretty good fit for teaching backend because many students already know Python. So if you look at colleges, a lot of colleges start either with Python or Java right now. I think at this point, it's probably more that are starting with Python. Like 10 years ago, it was more starting with Java, but it's slowly been moving over to Python because people like the kind of learnability of Python as a language as opposed to Java. Python is a nice starting language because it's multi-paradigm. So you could teach object-oriented, but you could also teach very functional. So it's a great starting language. So many students will already know Python, but they may not know it from a web perspective. They may have learned it, to do Pygame and make games, or to do data science and do analysis, right? Or just, CS 101 and the random things that we have you do in a CS 101 class. It's also a great language because it just has a huge ecosystem. So whatever you want to do with Python, whether it's for web development or otherwise, there are so many libraries for it. And then we can also use it for data science and AI, right? So we see actually lots of people coming over to Python for backend now just because of the interest in AI and the fact that there's really good support for generative AI in Python. There's so many packages for it. So I think there's increasing interest in Python as a backend language, even from folks that before wouldn't have used it. So what version of Python should you be using? The current version is 3.12. You can check this if you go to python.org/downloads and you can see active Python releases. Now, if you look at this, the very top one says 3.13, but that is a pre-release. So that is if you live on the edge, right? And if you're like a library maintainer and you really want to make sure things are going to work with the next 3.13 and give early feedback, then you'd want to be playing around with 3.13. Most of us don't live on that edge, on the wild side. So 3.12 is the latest stable, and that was released back in October. It's usually around October that they release. And you can see when it was first released and when the end of support is. So you see that 3.8 is approaching its end of support. So if you are using something earlier than 3.8, you should, really upgrade to a more recent version. And generally, the more recent and stable, the better, right? Because it's going to have better performance. And more importantly, for teaching and learning, it has better debugging. The CPython team and contributors have been doing amazing work with better debugging messages. And literally, I teach a Python class and there was some, issue that students were commonly having. And I reported it in the Python forum and said, hey, can we give a better error? And they added a better error for that situation, right? So it really is better debugging that will help you with the kind of errors that you will commonly see when you're, using Python and learning Python. Here's an example, right? So let's say I have this variable name that has a crazy name, Schwarzschild black hole. And then, I try to reference that variable name and it'll say, oh, that variable name is not defined. And then it'll actually tell you what it was supposed to be. So it's actually using spelling, like a spell check algorithm, like Levenstein edit distance, in order to say like, oh, okay, actually, this is really similar to this existing variable that's in scope, and it'll suggest it. So that's very cool. And so you can get this with names, you can get it with imports, you can get it with attributes. That's what I requested for my students. And you'll get this kind of message. We also have more, better debugging, like in terms of being able to pinpoint where in a line the actual error is. Getting better little carrots here for indications. So yeah, I would say, you should upgrade purely just for those better debugging messages. Okay, so let's talk about how you actually set up a development environment, right? Because I just said, oh, you got to use Python 3.12, and you might be like, oh, I don't want to have to my computer already has Python 3.9. I don't want to have to figure out how to update. I don't want my students to figure out how to update. And I totally get you. I hate touching anything about my actual base computer configuration. So there are other ways that we can set up development environments. So we'll see a few different ways. But generally, you do want to have some sort of dedicated developer environment. And this is something that is going to be common at companies, is having a standard form of development environment, because that makes it easy for any developer in a company, regardless of their operating system or machine or whatever, to all be able to work on the company's projects, and for it all to be replicable. So it really helps for a development environment to be replicable and isolated. Right? We want everyone in a company to just have an dev environment that works. And we want everybody in a class to just have a dev environment that works. So let's look at some options for that. So here, the first option you might consider is Python's VM. That is a built-in tool in Python for creating a virtual environment, right? So I can make one, I'll go ahead and make one in here just to show. Okay, where am I? Okay, CD, and I'll just go into some folder here, right, and make this bigger. So I can say python-mvm.vm, and so that says create a virtual environment and put it in this .vm folder. So that's actually creating a .vm folder inside this folder, and so I should see it if I, look at the contents there. And then I activate, which means I basically kind of am now working inside this virtual environment. And so whatever Python I created it with, that's going to be the Python of this environment, right? So I created it with 3.11, so that's Python in this environment. And now, importantly, whenever I do installs, when I'm inside this environment, the installs are going to be installed just into that VM folder, just into that environment. So this is super important to keep things separately, but separate between versions. So if we did pip install, OpenAI, and install that SDK, that's going to install it just for this VM, right? And it's important because you could have a different project that's using like OpenAI 0.27, and then this other project's using OpenAI 1.0, and they're going to conflict if you're trying to use them from the same place. So you can create a VM to keep it isolated. So that's nice because it's isolating our Python packages, and that's a great start. So at the very least, you should be using Python VM, right? And there should be support for it in your favorite IDE. There's definitely support for it in VS Code, and they're constantly improving that support. There's support for it in PyCharm. Those are like the two top IDEs used for Python right now. So try and get comfortable with VMs and being able to start those up and use them whenever. However, a VM is only good for isolating your Python dependencies. They're not going to isolate the rest of the environment, right? And when we're doing web apps, we have more than just Python, right? We're going to have, our front end, which we might be using JavaScript and NPM, installation for. We're going to have a database. So we're going to want to set up like a local, Postgres database or a Redis database or something like that. And you can set them up on your machine. And I even have a little elephant up here, which is my Postgres running on my machine. But it's really nice if you could also isolate that in your development environment. So you could potentially have multiple projects using, like different versions of Postgres, for example. So that's why I really like to use dev containers. Dev container is a way of defining a development environment for a project. And it uses this file in a repo, which is devcontainer/devcontainer.json. And it is based off containers. So you start off with some Docker container, right? This one starts off with a Python 3.11 Docker container. And then you add additional customizations. So and these customizations could be, IDE specific, right? So I'll say like, okay, in VS Code, I want VS Code to have these settings and have these extensions. And then once it starts, I want you to run this command, right? And so the advantage of this is that by using a Docker container for our development environment, we can isolate everything about the environment, right? We can put it all inside there. So both our Python packages and our database and any services that we need to use. And we can use these dev containers in a few places. So this dev container spec was started from the VS Code team, but increasingly other IDEs are starting to support it. So hopefully we'll see other IDEs pick up support for this, so that it's not just a VS Code thing. Right now, I'm just doing it in VS Code or GitHub, which we'll see. So one option is, once we have a dev container in our project, we can open it in VS Code. So I have, let's see, I have so many up in that are dev containers, but here's one. So this is just my Python project template dev container, which is kind of my starting template for Python projects, right? So here you can see that I've got the definition, I've got my VS Code preferences, I've got some commands that get run, and I am already inside the dev container. Now let me open it locally so you can see what the experience is like locally, right? So here I have it opened locally, and you can see at the very bottom, it prompts, it says, hey, this folder contains a dev container configuration. Do you want to reopen the container? So that's what will happen, is that VS Code will auto detect if you've got the dev container extension and there's a .dev container folder. It'll auto detect that and then offer to open it up in that container. And it also detects when something has changed about the dev container definition, which is what it just did there, because I did actually make some changes to it. So it said, oh, there's a change, we want to rebuild that container, right? So it's actually currently rebuilding it and running those post commands, and then done. So here I am actually working inside a Docker container. So this is a fully isolated environment, right? So if I look at my Python version here, it's 3.11. But what if I want to change that to 3.12? Because I was just saying, like, 3.12 is the most recent. Okay, configuration file changed, rebuild, and now hopefully I should get a 3.12. So this is how easy it can be to change Python versions, change any aspect, right? Like if we were doing Ruby or C or whatnot, we could bring in different versions of those as well. Now, it does take some time to rebuild. This is a Docker build process, so it can take a little time to build it. That's probably the negative dev containers, is that because it's a Docker container, it does take some amount of time to build. There's things you can do to improve the performance of that and have pre-builds and stuff like that. But usually you don't have to rebuild it. Usually, once you got it going, you're good. So now let's try it and see if I got 3.12. There we go. So that's how we, changed to use 3.12 for this dev container. Now, what I really like is by having a dev container definition in a repository, that also makes it easy to use in GitHub Codespaces. And I love GitHub Codespaces because it's entirely browser-based. And that means that people don't have to have anything installed. So this is what I use all the time for workshops, because I don't want to have to deal with making sure like people's machines have the right VS Code and extension and Docker running and all that stuff and enough Docker space, right? Like that's actually a lot to set up. Instead, I can just make sure they have a GitHub account and that they can log into the account, and then they're good. So we can look at like that same, here's that Python project template. That's what I just had open locally. In GitHub, I could go here and go to Codespaces and say create Codespace on main. And what that does is that it creates the Docker, the Docker container, and it's actually creating it like in the GitHub cloud. So this is a in-browser VS Code that is running a Docker container that's hosted on GitHub servers, which is kind of crazy. But the cool thing is that it totally works. Now, once again, the big drawback of Codespaces is that they can take time to load. But I was saying there is something called Codespace pre-builds. So if you have a classroom or a workshop situation where it's really important to have a very, very fast startup, then you could look into a Codespace pre-build, and so that way the image will always be ready. Okay, so then here it's running, and this is the version before I changed it, so this will be 3.11. And then we can do whatever we want in that code space. So this is VS Code working entirely in the browser. I love this because I love to do everything in the browser too. I would happily just always use code spaces all the time for everything. But there are limits. It's like for a normal account for GitHub, it's like 60 hours a month or so. And then I think for students accounts, it's like 120 hours per month. So the limits are pretty darn high. So it is, but it is good to eventually know how to work outside of code spaces as well. Okay. So there you go. That's some example dev containers. If you're trying to get started with creating a dev container, that part can also be a little tricky too, especially if you're new to Docker. So what I say is like find the most similar dev container to what you want and then fork it and make it your own, right? So I've got a bunch of links here to example dev containers that show, different sort of configurations that you might want, especially for Python. So I would say, start with the one that's most similar to what you want and then go from there. I mean, generally, if you just look in my GitHub, everything here has a dev container. So if you're looking for something similar, just check here and hopefully you can find something that's what you're interested in. Or a pro tip, go to GitHub search path.devcontainer.json. Let's say you wanted to see somebody who's using Redis. And then you can look to see what do other people's dev containers look like, right? Oh, there's literally a dev container for Rails. That's great. So that's something that I do when I'm, working on some sort of dev container that I haven't done before. I look at other people's dev containers and just get an idea for them. All right. So that was dev containers. Now let's talk about Python web frameworks. There are a few modern web frameworks that are popular, and we can actually see that in the JetBrains developer survey from 2023. So last year, 2023, the most popular was basically Django and Flask. They're basically neck and neck here, right? And Django and Flask, they've been around for a fair bit now. They're pretty established. And then Fast API was up to 25% last year. Now, I haven't seen 2024 results yet, but I'm guessing Fast API is going to be even higher because it's very popular, it's very hot, and it's growing all the time, and it's popular for good reason. I use it quite a bit now too. So those are our popular frameworks that we want to be aware of and want to decide which of these to use. Now, there is also an asynchronous version of Flask called Quart. It's not as well known, and in some ways, you could think of it as basically being Flask async because it literally is a built on top of Flask. Flask is a dependency for it. But I am increasingly using Quart, and we'll see why soon. So starting with Flask and Quart, Flask, it's a lightweight web framework that includes routing and template rendering. That's basically what it has to start off with, right? So routing means you define a URL and say, hey, this path is going to go and be handled by this function. Template rendering is the ability to take like a Jinja template and say, hey, we're going to render this template out. Now, anything else you want to do with Flask, you will need to use either write your own code or use an extension. So Flask has this huge ecosystem of extensions for common things you might want to combine a Flask app with, right? So there's Flask SQL Alchemy for a database ORM. There's WT Forms. There's Flask Session, which I used the other day. So you're generally going to be bringing in these extensions or just writing your own code. So that's the interesting thing about Flask is that it's very easy to get started with. But then once you do want to bring in more functionality, you have to make a decision about how you're going to bring that in, what plugin you're going to use, is it well supported, or are you going to write your own, et cetera, et cetera. So I actually think it's a great framework for just getting started to get the feel for, how does a web app work, but it can definitely be complicated once you want to do things like databases and user auth and all that stuff. So I have an example Flask app here, right? So Flask DB quiz example, and I started a code space for it, and the code space is running here. I just need to restart the code space. So I have my code spaces set to expire really quickly after 30 minutes, just so I can maximize my use of the quota. But that does mean I'll have to restart these code spaces when I open them. I should just go check if any other ones need to be restarted. No, okay. All right, so this one is restarting, and it's usually fairly fast to restart a code space. It just kind of has to rerun the image there. So this is for a Flask app that uses a Postgres database. So let me go ahead and run it. Okay, and you'll see that it says it's running and it says this is the URL and it looks like a localhost URL, but remember I'm in a GitHub code space. So I can't just, if I just put this in the browser, it's not gonna work because it's not really running on that local to my own machine, right? Actually, I'll get a different app. This is the one actually running on that port on my machine. Instead, I wanna figure out what is the GitHub URL for localhost, right? So what you do is you go to your ports and you can click on that port that's running and click on this little globe and it'll open up. And even if you command click here, typically that'll open up too. So command click doesn't work for me today for some reason. So here is my Flask app. It is a Python quiz and we're like Pamela, who invented Python, Guido, Pip, Monty Python, I think 1991. I always mess that one up. Oh, I got it all right. So that is storing everything inside a database, and the database is also running inside this code space. So this is what really is really cool, is that you can set up an entire web development environment entirely inside a code space, and your students or you don't need to set up anything else. So we can see that the Postgres is running here, the server is running here, and it's actually storing stuff in that Postgres. I even have the SQL Tools extension so that I can explore the local database. So we can go and find the questions for the quiz, right? And those are the questions you just saw, and those are the answers, spoilers. And this is just exploring that database that's running locally in this code space. So that is Flask. And, I didn't show any of the code for it. I was saying we're not going to go deep into the actual code today, but you can explore it if you want. You can also come to the workshops that we'll be having specifically on Flask. But basically, we get a route and then we do some database query and then we render a template with the results from that database query. That's our general approach to writing a Flask application. Now, Court is an asynchronous version of Flask, and increasingly that is what I'm using, especially for any of my apps that involve generative AI. For performance reasons, it's really, really important. So, if you are doing calls to OpenAI or large language models on, hosted somewhere, then I do recommend looking into Court as well. Okay, now Django. Django is a much different framework from Flask. It's highly opinionated. How it's usually worded is that it's batteries included. So it comes with all this stuff that you commonly are going to want to use. So it comes with an ORM, an object relational manager for database access. So it assumes that you're going to want to work with a database, and it has that notion of database access just very much baked into the idea of the framework. It comes with an admin interface, which is amazing. It comes with the ideas of forms, templates, and views. It has its own security features. It has internalization. It has its own testing tools set up. So all this stuff comes built in. So if that's the sort of stuff that you want in a web app, and that's what many people want, then Django is an amazing fit for it because it'll just, already be supported. So let's check out a Django app instead. So Django quiz app, and I created a code space for it. And once again, I need to restart the code space. I do, let's see. Yeah, I'll have to restart it and get it running. One thing I'll point out while that's starting up is that with these ports, you can, by default, these URLs are not visible. So if I, pasted this URL in the chat, you wouldn't be able to visit it. But what you can do, and this is super cool in a classroom setting, is you go to port, you right click and you say port visibility public. And now I could actually put this URL, in a classroom chat or something like that. And then other people would be able to see it. And that would work as long as the code space was running and, and this Flask server was running. So that can be really cool just for being able to quickly share things in with colleagues or with classmates. And I just think that's just a really nice feature. All right, let's see how our Django is going. Okay, so Django has restarted. So I'm going to run the Django server. And you see it actually gave me a little notification and told me where to go. So that's another thing GitHub Codespaces does. It auto detects when something's running on a port and offers to open up that port in a new window. So here is my quiz. And here, I'll get it wrong. And I can add more stuff to this quiz. So let me show you the admin. And this is what's so cool about Django, right? So here's my quizzes. So we have a pollinators quiz, and then here's my questions. And this is Django admin. So this is already provided out the bat without me having to do anything at all. So I can go ahead and add a question. What plant do swallowtail caterpillars eat? And we'll say dill. And save. Oh, and I gotta say the quiz. Okay, it does all this validation for me. It's so nice. All right, and so then when I reload, go back here. Let me get this right. Next question, dill. And there we go. So this is what's cool about Django. It makes it really straightforward to work with databases, and it's very opinionated about how you do things, right? So you always like structure your folders a certain way. So for example, you can see in here, we've got quizzes. Let me try to make this bigger. Quizzes has a urls.py, and that defines the paths and just points at what functions will handle them. Then you have views, which are the functions or classes that are going to handle those paths. Then you have models, which are the relevant database models. Then you have apps, that's for the admin, I think. And this is definitely for admin, which is admin.py. So these are like prescribed file names that you're always going to follow. So this works really well if your app follows this kind of standard scheme of wanting a database and user login and all that sort of stuff. And you just have to, as long as it fits with the opinionation of Django, then it's going to be really pretty smooth. And also the Django community is an amazing community. They're probably one of the most welcoming communities I've seen out there. So if you're having questions about Django, it can be a really nice community to get answers from. And that's always a good reason to pick technology too, because you're always going to have questions about everything, right? And it's good to know that you can ask them and get some nice answers. All right, so there's Django. Now let's talk about Fast API, which is the hot new framework. It is an async framework, and it's only async. So I mentioned Quart, which is an async version of Flask. Fast API is async and only async. That's how it started. It is targeted at building APIs, like HTTP APIs, which is how many people do build websites these days, is with having an API backend and then a JavaScript frontend that consumes those APIs. And it auto generates documentation based off of Python type annotations. So we'll just check out, what this looks like. Let's see. Okay. Of course, we'll restart the code space. We're getting good at this. So this, we'll start off with the simple one, which is simple fast API container. And this one is actually designed for specific use with Docker containers, but we can also use it outside of the Docker container. That's what we'll do. All right, looks like it's starting up here. So I'm just going to run the local server. I'm going to use Fast API to run it. The Fast API has a development server that you can use when you're testing. And you can see it showed me what port was running and recommended opening it up. And we get not found just because there's no route for the slash. But if I go to /docs, then I get the auto-generated documentation. And this is really, really cool. This is actually called Swagger documentation, comes from the Swagger library. And we can, use it to try out our API. So this is just a name generator. And you can see here, it shows the curl I could do to try it out. It shows the full URL. It shows the body. It shows the headers. So it's just really, really helpful to be able to have this, this documentation if you are building APIs. And let me just actually show the code for it, because the code for this is really, really short, because this is a very simple one. So let's see, it's probably here. Here we go. So create fast API. We say this function takes this query parameter, and so we're using Python type annotation, which is this colon string. So we say, okay, this parameter is a string, and that's how this documentation knows it's a string, is it's actually using this Python type annotation. And we say it's optional, right? We say it's optional, it defaults to none. So that's how it knows that this is actually optional, because we could delete that and this would still work just fine. So all of the documentation is based off of how we how we use, Python type annotations and default values in our code. And then we return back some dictionary that gets turned into JSON. All right, so now let's see if I can show you the fancier one. Restart that code space. So this is a static maps API. And this was inspired by my time at Google Maps, where we created the Google Maps static API, which is an API that takes in like a latitude, longitude, and outputs just an image, and which is really nice when you need it for like performance reasons or mobile or something like that. And I found this static maps package and was like, oh, could I use that to recreate the static maps API? Of course, the Google Maps static API is still around, so you can use that. But this one, you don't have to pay Google for. So this is a fast API app that makes a static maps API. This particular one I designed to work with Azure functions. Just as a demonstration of Azure functions. But you could also use it as just a standalone fast API app and just deploy it anywhere. I just thought it would be a fun thing to put on Azure functions. I was trying out functions. Okay, so we're going to open this up. And here we have generate map, try it out. And so here we've got a bunch of default values, right? And so let's go ahead and find the code for that, just to show, like, here's the routes, right? So generate map, we say, here's the center, and I have the default value, and I even have a regex pattern for validation. Here's the zoom with the default value. Here's the width and the height with the default value. So then we can look here and see all those defaults in here. And we even have a drop down for the tile provider. So let's try that out. And here we go. Let me try a different tile provider. Pretty cool. And we could try, oh, that one was a 500. Oh, so maybe that one doesn't work. Maybe you have to install that one specially. We can try a different one. It says 37, -122. Is that where I live, or is it the opposite? Okay, Santa Cruz. Yeah, I got pretty close. So that's just an example of, getting a little fancier with your API routes. So it's really cool. It's really interesting. If you want to, get into backend development, but you really don't want to deal with the front end, then being really API first could be a good approach, because there you're just focusing just on the backend, right? And you end up having these like nice clean routes that take certain parameters and give certain output, and then you can really test those routes really nicely, and you can be really disciplined about how you're testing. So you can see, I've got tests for this, and there's lots of interesting tests you can do for APIs where you can throw lots of different parameters at it and make sure it accepts everything correctly. Okay, so that is Fast API. It is really fun. Highly recommend trying it out if you haven't yet. And here is a brief aside on why async even matters. So let me show that code again, just to show what I mean by async. So if you look at, oh, did I not even put async in this one? Oh, let's look at this one then. Okay, async. This says async, right? So when you see async in front of a Python function, it means it is an asynchronous function. And that if any function calls it, it actually has to explicitly await the results from that function. So this is an async function, as opposed to like in our Flask code, where we have just a normal function with no async. So why does it even matter? Well, let's say I'm building an app that makes a call to OpenAI, and it makes a call to like OpenAI GPT-4, which can be pretty slow, like maybe take like 8 seconds, right? So let's say, I get a request in from the user, and I make a call to OpenAI, if it then takes 8 seconds to return, that whole time my app is just sitting there waiting for the response from that call, and that, the process that's processing that user request cannot do anything else, right? It just has to wait for that call to come back. So that's 8 seconds where the process is just sitting there doing nothing, waiting for the results of a network call. And only finally, once it comes back, then is it free to finish the rest of the response and then process a new user request. So what we found is that, we would deploy these Flask apps and we would do load testing on them, and we would discover that they would fall over really quickly when we had these OpenAI calls, because the workers, the processes, were just getting so much contention from having to wait for these long AI calls. So then, we port these apps over to an async framework like Core or Fast API. And when we do that, what happens is that it'll go in, it'll make this asynchronous call to OpenAI. And while it's making that asynchronous call, that worker is now able to start processing a request from another user. So it can do anything that's necessary for the beginning of that user's request. And then there might be another, call to OpenAI. So it's giving us the ability to have more concurrency than what we would have if we weren't using async. So it's not something you always need, but if you have any sort of slow IO calls or network calls or database queries, then it's really good to consider async, especially when you're going to productionizing. Now, in a classroom setting, probably doesn't matter, right? You don't need it, but it could be a really fun topic to learn about and to teach about. So I would consider introducing it just from the computer science perspective, because I'm still wrapping my head around concurrency, and I remember first learning about it, I think, in middle school, but not well. So I do think it could be a good topic for a classroom. So now you've seen, the top frameworks. Which framework should you teach, or which framework should you learn? So I like to teach all of them so that students can eventually become framework agnostic and realize what is particular to a framework and what's kind of generic across all of them, and so they can pick the best tool for the job. If you do need to choose just one framework to start off with, Flask can be a good one for getting started if you're doing something really simple and you're staying really, really simple and not adding on databases or anything like that. But if you are going to start to get any more complex than that, then I would caution on Flask. Django includes everything, which is great if you are eventually going to need database and user admin. But if you're not, then it's kind of too much to learn at once, I would say, and not necessarily worth it. And then Fast API, easy to get started, and it's just a really good fit for APIs. So, if that's what you're building, then I think that's a really straightforward pick. So yeah, it depends what you think the scope is of the project, and what you think you're gonna end up reaching for, what you're gonna end up picking. We are gonna do workshops covering them in June. So starting on June 4th, we're going to talk about Flask and Quart. On June 6th, we're going to talk about Flask and SQL Alchemy. On June 11th, we're going to talk about Django. On June 13th, we're going to talk about Fast API. And then we're going to have some talks about containerization and testing. So if you want to really get into these, then I do recommend coming to the upcoming workshops where we'll actually, explain these frameworks and dive deep into them. So now let's talk briefly about databases. So, in 2024, we've got two main database options. We have relational databases, and that's kind of the, more traditional database that we think of, which is, Postgres, MySQL, SQLite, Microsoft SQL, that sort of thing. And then there's also NoSQL databases, which is like MongoDB, Redis, all sorts of other ones, MariaDB. So if we look at, once again, the JetBrains Developer Survey, what we see is that MySQL is still the most popular, and that's been around for a really long time. It was definitely my first SQL database. It's what I used in high school. It's what we used at Coursera, actually. I can remember going to the MySQL admin to fix some issues. So it's still very popular, but increasingly Postgres is really, really popular. And Postgres is an open source database, and it has really great community. We've got a conference coming up for it, June 12th, that I'll be speaking at, and it's virtual. So, come over to our Postgres conference. And yeah, that's just increasingly popular because it's a very powerful SQL database. It can do quite a lot, and it does have this open source basis that people really like. We can also see that MongoDB and Redis are fairly popular, as well as the kind of NoSQL options there. So let's talk a little bit more about Postgres. As I said, it is open source. One of the reasons that people really like it is because it does support lots of different data types, and it has lots of extensions for things that you might want to do. So it does support JSON, and I think it just supports that one natively. But if you bring in an extension like PostGIS, then you can support, like latitude, longitude coordinates and distance operators really easily. If you bring in the PG vector extension, then you can support vector embeddings and vector distance functions really easily. And that's what I'm going to be talking about in the Postgres conference. And there's lots of other extensions like that. Those two are some of the more popular ones, but there's extensions for, different data types, but also extensions for just administrative type stuff like PG Bouncer, which is for handling like connection bouncing and stuff like that. So great database, great community, great ecosystem. In Python, you're typically going to be using first a driver and then maybe an ORM. Do I talk about that? Yeah. So the driver is usually going to be, that's the thing that actually connects with the Postgres database. So typically that's going to be either PsychoPG, or if you're doing async, you're going to use async PG, right? So it depends whether you're doing sync or async. And then I always recommend using an ORM, right? So SQL Alchemy is an ORM, an object relational mapper, and it allows you to write object-oriented Python code in order to describe your database schema, in order to interact with it via, actual Python calls, as opposed to writing raw SQL. I do occasionally write raw SQL, but I feel much safer when I use an ORM because it's generally going to protect me against SQL injection attacks. And so if you can use an ORM for your use case, I do always recommend using an ORM, and that's what I use for most of my samples. I know teachers sometimes like to do stuff in raw SQL so that they can also teach SQL to students, because SQL itself is a good skill. So I do totally use SQL queries when I'm trying to, do data analysis, because there I'm just doing a read-only query, and it's okay that I'm not gonna suffer an injection attack because I don't even have write access at that point. But whenever I'm potentially have write access to a database, I really like to use an ORM in order to, make sure I'm doing things in a safe way. So this is with the SQL Alchemy ORM. And I've created some, dev containers that make it really easy to, try out the ORM. So this is my Postgres dev container, and you can see it already has SQL Alchemy example built in here. I even started it up. So here we go. Let's see if it's still running. Restart CodeSpace. I should have restarted each of them right before it. Let's see if that'll fix it up. Okay. Oh, I've reached the maximum running code spaces. Okay, that's fair. I did start up quite a few. But anyway, you can run this SQL Alchemy code, and you can use that VS Code extension to explore it and see how it all works. MongoDB is a NoSQL database, so it is document based. So instead of having these like tables with the relations to each other and doing joins and foreign keys and that sort of thing, instead you store data in these JSON-like documents. I have not personally used MongoDB, or at least I haven't used it successfully. So I'm not an expert on it. But it is fairly popular, as we saw. There are definitely Python libraries for it. So PyMongo would be your general driver for it to actually connect to it. And then Beanie is an ODM, which is an object document mapper, which you can use to, describe your documents, schemas using Python classes. So that's what you can explore if you are interested in MongoDB. Redis it's sometimes called a database. I think of it as being like a a memory key value store, which, you can use as a database. But it's a little bit different where there's different use cases where you could use it for. So I actually recently did use Redis for one of my samples, which does user authentication. And I'm using Redis in order to actually like store the user sessions, right? So I'd store a session ID for the user and put it in that Redis. So that's a really nice use of Redis, like where you just need a key value store and you know what you want to, what you're going to pull it out, what key you're going to pull something out based off of. You don't need all this fancy relational stuff. And the cool thing with Redis is that we can set it up in our dev container as well. So if you look at the dev container, I set it up actually using a Docker Compose. So this is a file that defines multiple images. So I use Python 3.12 for the actual source code. And then I bring in the Redis image and set that up locally as well. So yeah, so you definitely can easily develop with Redis and set that up in a development environment, and it can work really well there. And it's good for particular use cases where you really just need a key value store. I wouldn't use it as a whole on database because it's really not, but it's great for a key value store. So if I was going to pick, I would go with Postgres. Just really like it, love the community, love that it's open source, love how easy it is to get set up with the dev container for it. But once again, it's depend on what it is you're trying to learn or teach with your web apps. But generally, SQL is a great skill to have, right? So having more exposure to SQL is pretty much always going to be a good thing because I don't see SQL going away anytime soon. We are going to have several workshops about databases, right? So we're going to talk about databases and ORMs on June 6th, but we'll also talk a bit about databases during the Django one. So come on over to those in June. Now let's talk about containerization. Let me close my billion tabs. As I mentioned, there's a lot to talk about here, and I'm impressed if anyone is still watching. But I wanted to make sure I had a recording of this for anyone who's interested because I knew a few teachers were asking about it. So now let's talk about containerization with Docker. And this was actually based off a conversation I had with a teacher. They're wondering, like, should students even need to know how to set up their local environment, right? Or will things always be set up for them in some sort of cloud? So I think that an essential skill is containerization with Docker, because basically what I've discovered is Docker is everywhere. Okay, we're using Docker for our dev containers. We're using Docker for deployment. Even when we don't even think we're using Docker, we're using Docker, right? So even when I'm not explicitly writing a Docker file, a lot of times behind the scenes, the tool I'm using or the deployment host I'm using, they are actually using Docker. So understanding the language of Docker and containerization and all that, I think is going to be helpful for new developers going forward. So what even is Docker? Okay, so we have our operating system running on some hardware, and there's a Docker engine running on top of that operating system, right? And so you can actually see I've got my Docker running up here, and it's this cute little whale with ships on it. It's the whale is the ship, and it's got containers on it because it's supposed to be like a cargo ship with containers. So Docker is running here, and I could even open up my Docker desktop here. And that also means that Docker, the command that I can, run a Docker command here, and that, that's running as well. Okay, so Docker's running. So once we have a Docker engine on the operating system, now we can run containers with that Docker engine. So if we look at my Docker desktop, I could look at containers and see what I have running. I usually have several running because I use dev containers so much, right? And these are actually the dev containers that we were running. So we can actually see them and see, they always get these funny names. So that's the one that's running right now. That's that 312. Remember, we changed that to 312. So that there is a container running based off that 312 image. And then there's a few other containers as well. So once we have a Docker engine, we can run lots of containers on top of it. And each of those containers is their own isolated environment. And that's what's so, so brilliant about Docker is the ability to have these fully isolated environments so that we could have, we can have different versions of Python in different containers, different versions of Django's and databases. All of that can be different across these containers, and that's not a problem whatsoever. So these containers are based off of images, right? The image is like the definition, and the container is a running instance of that image. So these are a bunch of images that I have locally already. You can see I have 55. A lot of times I prune these out just because I have too many things. But you can see these are all images. So for each of these images, I could run a container based off this image, and I could run multiple containers off the same image if I needed to. So that's the kind of terminology, right? The container is the running instance of an image. The image you can think of as the definite, like the actual software package definition that will get that container running. So in order to build a Docker image, we need to describe what should go in it. So that's what we use a Docker file for. So this is an example Docker file here. Right, so this it'll start with a base image, and so usually you're going to start from some existing base image, like maybe just a Linux version, like a Debian, or here I'm starting from the Python, the official Python 3.11 image, because I'm going to run a Python app, and then I copy some of stuff over, I expose a port, and then I give the entry point command. So this is the command that's going to run once that Docker container starts. So this code here is actually running a Python web app. And I think we can probably have one of them. Let's see, is it here in here, VI source Docker file? So we can see what it looks like. This is what it looks like for the Fast API app. So it's pretty similar to what I just showed, but exposes a different port and uses a slightly different command to start it off. But then once you have that, then you can actually, let me look at the instructions in the README, just remember. So we're going to Docker. You can see how good I am at Vim. All right, so build the image, right? So the first thing you would do is build the image. Bum, bum, bum. So this is going through and actually executing each step of that Docker file. And the speed of this is going to depend on whether it has any of those steps cached, because it can actually cache every step of the Docker file. And so it'll check to see if it has in the cache. I think in this case, it didn't have any of those cached. So it is going through and doing each of them, from scratch. And you can see how long like each of the steps take. Okay, so that is now, it's built the image. So we have a Docker image now, but if we want to actually run it, then we use Docker run. So let me look at the README for that, right? So we're going to run, we tell it which ports to expose to our local network. Okay, so this is running, and it's actually running using multiple workers, so they can scale a little bit. And it says just running on my local machine, so I think this will probably work here. Yep, and then we can go to /docs. And this is the same one that we showed in Codespaces, right? But here I ran it with with Docker commands, right? So generally you do a Docker build and then a Docker run. So why should you use Docker? We've already seen the benefits of dev containers, and it's really similar benefits, right? Consistent environments, isolated from host machine, easy to set up. And then for production, that's where you get a huge number of benefits as well. And that's probably why we see so many production hosts are based off of Docker, right? Like so much of Azure, or maybe all of it at this point, is like based off of Docker containers and running those, because it makes it way easier to scale something, right? If we know how to replicate this application, then we can scale it down to 0 if there's no traffic going to it. And then we can scale it up to like hundreds of machines if there's lots and lots of traffic going to it, because all we have to do is every time we need a new version of it, we just run this Docker run with that image, right? So it makes it much easier to scale something because we know exactly how to create a new version of that app. And it's, Docker is supported by pretty much all the cloud providers, have ways of running containers because it's so popular. And so that way you could actually test your app locally using the same, basically the same command that's going to be used for running a production. So you have better replicability between your local environment and your production environment. And then you also have more portability across cloud platforms, right? So I talk about Azure since I work for Microsoft, and all of my examples are built for Azure. But actually, any of my examples that have a Docker file or Docker Compose, you could take that sample and you could deploy it to any cloud, right? Because it's it should just work there, because it's just a Docker file, right? So there's this portability that people really like as well. So lots of benefits to understanding how to use Docker. And we will be having a containerization workshop to go more in depth. So check that out if you want to learn more. Okay, so now let's talk about coding assistance. And I think that coding assistance is an essential part of modern programming, modern development, because it's just not reasonable for us to be able to code everything from scratch with no assistance at all, because we're working with so many tools, so many technologies, and everything is changing all the time. We can't physically fit everything in our head, right? I've tried, I can't anymore, right? It's really, really nice to have assistants that can help us out and say, point out when something's wrong, remind us of what, functions we can call. So I think understanding how to really utilize coding assistance is a really important skill for web developers going forward. So what do we even mean by coding assistance, right? There's many different coding assistance tools, right? We can start off with the basic, which is just IntelliSense, right? Which is just getting like little pop-ups and auto completions when we're in an IDE. Then there's debuggers, which can help us step through our code and find the problem. Then linters, which can point out when something's wrong. And then formatters, which can make our code nice and pretty and consistent. So let's actually, try this out. So IntelliSense, right? Hopefully this is something you've seen before, but right. So let's see what sort of IntelliSense. I have Copilot enabled. So let me go ahead and disable it right now, just so we can see just Copilot and see what would happen if we didn't have it. Now this one's gonna be hard to get IntelliSense. So let me go over to a full-fledged app where we have lots of things, right? So let's see, auth claims is a dict. Okay, so auth claims dot. All right, so here's a good example of IntelliSense, right? Auth claims, it knows is a dictionary because I used a Python type annotation here, and that's a nice reason for using type annotations in your function signatures. And so then when I typed auth claims dot, it popped up with all the, possible things I can do on a dictionary, and it prioritized the things that, the standard things and not the dunder things, the things with the double underscores. Those are the dunder methods. So here we can say, get. Let me go back to get. Let's do that again, get, okay. And then here, when I do the parentheses, I can actually see the signature for it. It says, okay, it takes a key. Okay, so then I'm gonna pass in the key. All right, and then I could also look at the return value. Let's say x equals, okay. Is it gonna say, well, it's giving me, now we're seeing the linting and saying, okay, this is not accessed, right? So that's an example of the linting. So yeah, IntelliSense is gonna give you ideas of, how to use things, right? So these, the little pop-ups and drop-downs and all that sort of thing, that's the IntelliSense that we want. So your IDE should have it. In VS Code, you should use the Python extension, and that'll include Pylance, which will give you IntelliSense for Python. Now let's look at a debugger. Now, traditionally, people use prints, print statements. Certainly a lot of, students will start off with prints. I mean, I use print statements half the time too, but we really want to try and encourage more people to be able to use a debugger, because it'll make you a much more powerful programmer, because there's only so much you can do with print debugging. So here I am in VS Code, and I've got the Python extension, and I set a breakpoint, right? I just do that by going in the gutter here and setting a breakpoint. And so then I can click on the debugger, and I'm going to debug this file here. And so that gets the Python debugger going. And so here you can see that it has paused, and I can step through the code. And as I'm stepping through, I can look on the side here. I'll try and make that bigger. I can look on the side and see the variables and as they change, right? So we see, okay, this is the list of scores. Here's the current total. Okay, as I go through the for loop, I can see as the total changed. And so this can give me a better idea for what my code is actually doing and help me figure out, where bugs are in my code. So there we go. So that was a Python debugger, and that's definitely a skill that is really, really valuable to have, is knowing how to get your, how to set breakpoints, how to use your IDE's debugger. And for VS Code, you can use the Python extension once again, which includes a debugger. Then there's linters, which will, fix bugs. And we actually just saw that, pop up on the other one. But here's one where I have lots of bugs, right? So I have OS is not accessed, and I'm getting lint errors from multiple extensions because I got Pylance and I have Rough, and they both want to point out how bad this is. Here, similar, it's telling me that I'm using a variable that's not defined. So it's really, really nice to have this immediate feedback that something is wrong, especially as people are increasingly using, AI assistants, or even just using Stack Overflow to get ideas for how to write their code. Like when you're bringing in code from elsewhere, it's great when it works, and it's great when it helps you solve a problem. But you might accidentally bring in some buggy code, and the earlier you can find about that, the better. Now, of course, ultimately you should do tests, which we'll talk about soon. But if you can find out about that buggy code early, like immediately as you're typing, or when you press save or whenever, then that's going to be really helpful for finding things early. So for linters, you get some amount of linting from Pylance, which is part of the VS Code Python extension. However, you can also use Rough, and that's what I like to use for all my linting. And I always run Rough across all my files before I check them in, and on my CI and all that stuff, right? So let's see, I can do Python Rough check, and I'll just point it at this file. It says no module named Rough, so that's fine. I'm just going to pip install it into this environment. So Rough is a third-party package made by the Astral team, which is led by Charlie Mosh. And I worked with Charlie at Khan Academy, and he was a great guy. He's a great guy. So it's great to see him working on Python tools. Okay, so here we can see the results from Rough. And here we're seeing the same things that we see in the browser. But it's nice to have this command line check as well, because I can run this on pre-commit, and I can run this in my GitHub action for CI/CD, right? And this is what I do always run, is this Rough check. So you want linting on demand in your browser, and you also want linting as part of your workflow. Finally, formatters. So a formatter is not strictly necessary, because if your code works, it works. But I think it is so nice when all the code in a code base is formatted to a consistent style. I had a really hard time when I was teaching at UC Berkeley, and I would see the very, very different code formatting styles from all the students, because I'm used to PEP 8, which is the kind of the Python standard for how you should lay out your code and how your spacing should work and all that stuff. So I actually have a really hard time looking at code that's not PEP 8 compliant, because I'm just so used to that being the way that Python code should be formatted. So I think if you want to make it easier for your colleagues or for your fellow classmates or for your teacher, then it's nice to be using a formatter and to agree on what formatter and formatting rules you're going to use. The most popular one right now is called Black. And let me do a pip install of Black as well, so we can run that and see what it does. Okay, and then so I'll just go ahead and run Black on this file, buggy.py. Let's see if it makes any changes. Path. Oh, yeah, sorry. I just made up the function. Okay, just Black. Okay, and it reformatted. So you can see what it did was 2 blank lines between. It did a little space there. And these are all things that I really like, and that makes it easier for me to look at code. Now, these days, you can also use Rough for formatting. So I'm increasingly moving to Rough just because I like having a single tool. So if we do Rough format, then you can see it didn't change it because Black had already fixed it up. Black and Rough are pretty darn similar with their formatting, but we can try, let's try really messing with it. Okay. And go like this. Okay. And there you see that Rough reformatted it to the exact same way. So you can use black, you can use rough. The important thing is just to use something and to agree on it, and to have it as part of your workflow so that you can all have beautifully consistent code. And that might be hard to do in a classroom setting for sure. But definitely in a company setting, that is something you'd want to find a way to just to enforce, so that you're not arguing over what spaces are correct. And then, of course, we have to talk about Copilot. I am actually a massive fan of GitHub Copilot. It's been so helpful for me. So let me go ahead and turn it back on. And the reason it's been so helpful is because I have a 2-year-old. She actually turns 2 today. We're gonna have a birthday party tomorrow, so don't worry, I'm not skipping it for this. I wouldn't do that. But I have a 2-year-old, and I also have a almost 5-year-old. And that 2-year-old has been sleeping on me for like the last 2 years. And while she's sleeping on me, I'm like super bored. So I want to do something during that time. And so I've been coding. And the only reason I've been able to do so much coding is because of Copilot, right? Because I have very limited use of my hands when she's sleeping on me because it's really weird positions. But with Copilot, I just have to type a few letters and it figures out what I want. So from an accessibility perspective, I absolutely love GitHub Copilot. And I also feel pretty comfortable with the code that's generated. I know there's concern about, is this code, from someone else? But when I see the code that is generated, it's just doing a really good job at pattern matching, especially for web development code. Because with web development, so much of our code looks really, really similar because it's just so standard what we're doing. We have a route, we get some parameters, we do something with it, we return a response. Like Copilot can see that and they can really detect the patterns in that and figure out what comes next. I think it's just recognizing all the patterns that are really inherent to this very repetitive web development code and just helping us write that. So I think it's particularly well for writing web apps. I wouldn't use it for like an algorithm class for sure, but for a web app development class or web app development setting, because I am a professional web developer as well, it's really, really, really good fit. And there is a GitHub Copilot for students, which you can use if you're a student, and hopefully, or you can get Copilot from your company if your company is enrolled, or you can pay for it personally. So there's many ways to invoke Copilot, right? So the way I use the most often is, in the editor, right? So you can see here that this is what we call the ghost text, and then I can just tab to accept it, right? And it pretty much understood what I wanted, right? And you can really help it out by giving it more context, right? Like start, end, and it knows, what I wanted to do there. And it can also suggest even multiple times when it thinks that there's, multiple lines necessary in order to answer some code. You can also do chat, and I do use chat sometimes. I used it to help me write a lot of matplotlib the other day because I'm not a data scientist, so I'm not an expert at matplotlib or NumPy. So if I ever have to use something that I'm really uncomfortable with, that is when I go to the chat. So I think it's brilliant for helping you with like languages or packages where you only use them occasionally and you just really need someone to give you some ideas. I also use it for bash commands all the time, like bash command to check ports open on a Mac, right? I asked Copilot for this all the time, and I finally actually did memorize it the other day. But it's really useful for bash commands. So chat can be really, really helpful. And then there's also the context menu, and that's where you can select some code. And then when you select the code, then you can ask it to to do some stuff. So we can say explain this, fix this, generate docs, generate tests. I haven't used this as much, partially because it's just hard for me to select when I have a baby on me. And also just I think it still needs a little bit of improvement, but it's good to know about these options and just play around with it, right? Because the most productive programmers will be the ones that can use these tools to their best advantage. So, try it all out, see what works for you, try it in different contexts, and then you'll get better and better at it and be able to be super productive with it. I have tips for how to prompt Copilot. I've got a blog on that. I've got a video on it. But the good thing is that a lot of these tips also just generally improve your code quality anyway. It's good stuff to do, like being predictable with your naming conventions. I think actually Copilot is fascinating from an API design perspective because if Copilot suggests something different than what you were going to write, it makes you wonder like, wait, actually would Copilot's code be clearer and more straightforward, especially when it comes to stuff like parameter names and return value names, like all these kind of naming things. So yeah, if you yourself are very predictable in the way you name and structure your code, then you're going to get the most success out of tools like Copilot. So check out those blog and video if you're interested in that. And of course, everyone's worried anytime we deal with these generative AI is how do we avoid hallucinations, confabulations, making stuff up, whatever you want to call it, right? So one thing you can do is that if you're using a library and you're trying to get code for that particular library, is that you could start off by pasting an example code from that docs just to kind of set it on the right path, right? And that'll make it seem like, we're using that version of the library. Okay, I'll use that, right? Generally, you do need to be careful when asking about anything niche, right? Because it might make something up. But that's also why you want to use IntelliSense and linting and stuff like that to let you know immediately when something's been made up, right? And of course, also why you want to write tests, which brings us to testing. So here is the classic testing pyramid. So we've got unit tests on the bottom, E-to-E tests on the top, end-to-end tests, and then integration tests in the middle. And this pyramid represents generally like the quantity and then the time it takes to make these tests. So you can have lots and lots of unit tests because there's lots of little units in your code to test, and they're generally pretty quick to write. But then you also get less return on investment, right? Because you could have a unit test that's only testing like 2 lines of your code base, right? You could have 10 unit tests that test 2 lines of your code base, and they could be really easy to write, but then they're only testing 2 lines of your code base. So that's why we say like the return on investment is low for them. Now, end-to-end tests, they're going to take longer to write because an end-to-end test is literally like, okay, we open the website, the user logs in, the user checks their profile, the user changes their name, and the user sees their new profile updated, right? That is an end-to-end flow for the user. Those tests can be a lot more difficult to write because you might have to use a whole browser for that experience. You might have to mock out some libraries like authentication libraries, so they can be a lot harder to write, also slower to run, because in this case you have to go through this whole flow, even open a whole browser. But the return on investment is huge because now you verified that a literal user flow works. You now know for sure that yes, a user can log in and change their profile name. So the return on investment is huge. So traditionally people would start at the bottom and then work their way up. But these days, some people are starting to advocate starting at the top and working your way down, right? And I say just at least start somewhere. I worry that there's too many code bases that don't even have any tests at all. So at least start somewhere. I think what's nice is if you can do one end-to-end test and one unit test, at least start with those, because that'll make it easier for other people to write an additional end-to-end test and additional unit test. Because the first one is always going to be the hardest because that's where you have to like set up your testing framework and all your mocks and everything, right? So if you can start off with a basic end-to-end and a basic unit test, then that'll make it easier to add more as you go down the line. So as to what you write, it's going to depend on you, your resources, and the app you're building. But keep in mind the various trade-offs here. For Python, these are the most commonly used unit testing libraries. Unit test is what's built into Python standard library, but it was based off the Java unit test framework. So it's pretty verbose, it's pretty Java-y. It doesn't look very Pythonic, right? PyTest is a third-party package. It's very, very popular. I'm like in love with it. It's really nice to use. It feels very Pythonic. It doesn't feel like Java, and it's got such a huge community and ecosystem around it, and it's easy to write plugins for. So that's what I tend to use in a lot of my tests. I will often bring in additional libraries built on top of it. So like PyTest Snapshot is for snapshot testing. So that's like really good for APIs if you want to make sure like, okay, the result of this API call is always this long JSON, right? And you just store those snapshots in your code. Hypothesis is property-based testing, and that's really good for APIs too, where you can say, hey, this API takes an int, a string, and a float, and Hypothesis will send all sorts of different strings and ints and floats at the API and make sure it's returning the way you want it to return. So it's going to test all the edge cases, right? It'll test like really big numbers, really small numbers, very negative numbers, fraction numbers. Like it'll test all these edge cases that you might not have thought to write tests for, and let you know if something goes awry. So that's a really, really nice fit for API testing. And that's where you can really start to gain a lot more confidence in, in whether your code is fully covered, right? Because even if you do, PyTest and have 100% coverage, you might still be missing something because you're missing edge cases for parameters. But I'm saying like coverage, right? Code coverage is something you do want to be implementing. This is something that's going to measure how much your code is tested by your tests. And we use this at UC Berkeley when we were teaching web development. We told students that they had to have at least, for the final, it was like 75% code coverage, I think. So we would actually check on their code coverage because we'd put it in the GitHub CI tool so we could see in their CI what their coverage was like. And so it is totally something that you can enforce for classes, for companies, right? So I have a lot of my GitHub repos I cannot merge to main unless I meet the minimum threshold for code coverage, right? So you can see example here, required test coverage is 86%. And here we're at 89%. And this is with an actual repo. And you can even click through and see it here. So this is, this is one that I enforce code coverage. So this is a really, really useful tool, both, in all sorts of settings, classroom and corporate. Now code coverage is going to tell you then how many lines were covered. And you can add branch coverage, which is if you have an if statement, like how many possible ways of going through the if statement were covered. And that's even more comprehensive to make sure like all the possible paths are covered. And then the final thing would be if you can use property-based testing. So I would only have full confidence in my code if I had 100% line coverage, 100% branch coverage, and I used a tool like Hypothesis to do property-based testing. Now, most of the time, I am not able to set up all of that, but keep in mind the sort of tools at your disposal and what makes sense for what you're using. Now, you can also do end-to-end testing, which is when you open up a browser and you actually, interact with a website. So this is definitely something you want to consider when you're developing web apps, because this is how you can test end-to-end flows. Traditionally, I used to use Selenium. These days, I'm using Playwright. Playwright's from Microsoft. It is really, really nice. It's generally less flaky. It's generally faster, which is good for end-to-end tests because end-to-end tests can be really, really slow. Right? And we can run them in our CI. We can run them locally. We can save artifacts, little traces, and when they didn't work, and we can actually like go through and see what didn't work. And so it looks like this, right? We go to some URL, we click on something, we check what we expect to happen, and we can even use this to check for accessibility violations, which is what this line is doing here. So that is what I recommend for end-to-end testing, is using Playwright. I've got some, and that's got some videos and blogs about that. And then finally, like, how do you integrate testing into projects, right? So you can run them locally as you're making changes. You can run them on CI/CD, and you can set your code coverage thresholds. For student projects, there's kind of two approaches. You could give them the tests, and you could ask them to write code to pass the test if you want them to kind of experience test first development. Or you can give them the code and ask them to write tests. Or you could, of course, ask them to do everything. But then it might be harder to compare across students. And we are going to have a workshop on testing. That'll be our final workshop on June 20th. So if you're interested in digging more into testing, come to that workshop. John Aziz did actually have some questions that he queued up about testing. So let's see if I can try to answer them now. But these are also good questions for the testing workshop. So John says, let's see the question. What is the best practice for testing external tools that I'm using in my website? Some tools may require subscription or making calls to paid services. How should we handle this? That's a great question. And it's one of the trickiest things of making websites. So I'm trying to find, I'm gonna see if I can find this amazing blog post about it. There we go. Writing tests for external API calls. This is let me make sure. Yeah, so this is a long blog post that talks about many different options for this and what the trade-offs and benefits are. So I definitely recommend checking this out. This is Cosmic Python Writing Tests for External API Calls. And he really talks about a lot of stuff. So my answer is that I do mocking, right? You can see this, if we go to the OpenAI demo, which is repo that John also works on. So he maybe have seen this, but if you look here, I've got mocks, right? So my mocks, I can mock out all sorts of things, right? I mock out, I mock tokens for the credential. I mock the AI search and the results they give. I mock the OpenAI client. I mock computer vision client, right? I'm mocking all of these server tools. So, this can work pretty okay. But there is a danger to too much mocking, especially at the kind of level I'm doing it here, where I'm mocking like at the function level, because what can happen is that you can have an issue in production where my mock assumed something about like the underlying interface, and that was a wrong assumption, right? So, definitely these mocks enable me to test the code around these service calls, but they make assumptions of the service calls and how they're working, right? The only way I could the way I could have a better mock is if I was mocking on the HTTP level. And that's, talked about in this blog post. Like if I mocked at the HTTP level and said, you get this network request and then you give back, this response. And I do actually do that only in one of them. I managed to mock at the HP level. Let's see. Oh, it's not in that one. It is a lot trickier to, maybe I even deleted it because it's difficulty of it. Yeah, it's harder to mock at the HTTP level because you have to know exactly how like the client is going to make those HTTP calls. So it's a great question. You can get pretty far with doing mocks and monkey patch in PyTest. And there's lots of examples here of how we do lots of mocks for this one, to work with lots of Azure packages. You can, for whatever you're working with, you can just search for like PyTest mock and then that, that thing you're trying to mock. But it does mean that you'll end up with holes in your coverage, right? Because your mock has made an assumption. So the less assumptions your mock can make, the better, but it's going to be harder to write the mock. And it's just gonna be harder to write the mock. Sometimes I'll write a new feature and I totally have the feature done, and then that only took me a couple hours, and then it takes me like a whole day to write the mocks, which is really embarrassing. But it's sometimes it can be really hard to write the mocks if you're trying to do it like at a really low level. So I think generally we need to make it easier to mock libraries. So if you're in charge of a package or a library or service, you should include in your documentation, this is how you mock this service, right? That would be amazing if every Python package or API said, this is how you mock this service. And, and then everyone would just know how to do it. Because right now I think we all like kind of make it up from scratch, and it sucks because it's hard. So yeah, that's a really, really great question. All right. So great. And, I was saying we'll have the follow-up about testing, so we can dig more into that stuff at that session as well. Oh, and I have another section about cloud deployment. All right. So we'll talk briefly about deployment, right? So typically you do want to talk about how to deploy something. And this is something you want to learn as a student or a new web developer, right? Because you want to make your app accessible to others, right? And you want to get experience with all these different cloud services and think about security and performance and scaling. I'm going to talk about Azure since that's what I work on. And there is an Azure for students. If you're a student, you can get these, start with credit. Azure has lots of hosting options. So we've got Azure App Service, Azure Functions, Azure Container Apps, Azure Kubernetes Service. So generally, I would say that if you are learning Docker, then Container Apps is a really nice one to use. It's very Docker centric, but also doesn't require much knowledge outside of a basic Docker file. If you aren't learning Docker, then maybe go with App Service, where it's going to basically set up the Docker for you. And then there's Kubernetes if you want to get really fancy. I haven't even done that yet. And then there's Functions, but that's only if you really specifically want Azure functionality. There's also lots of additional Azure services, and this is generally the case with all cloud providers, is that there's just this many different services, and what you're going to do is basically like hodgepodge these services together depending on what you need, right? So you might want app service with Postgres and Redis and then a CDN, right? And you combine all the things for exactly what you need and nothing more, nothing less. And we've got a huge number of services, and these are some of the ones I've used, but there's many out there that you may want to combine based on what it is that you are building. Here's an example: Azure architecture for an app service app, right? So we might have the app service, and that has like a scaling plan, and then it connects with the Postgres database, and then we might store a secret in the key vault. Increasingly, we are trying to move away from having secrets at all and using something called managed identity, but it's good to know just even how to store secrets securely. And that's something, when you're learning about how to develop web apps, you need to think about security, and you need to think about performance when you're going into production, because ultimately that's going to affect like a real live app. In terms of how you deploy something to Azure, there are so many different ways, right? So you can just use the Azure portal, which can be good for folks who are getting started. You could use the VS Code Azure extension if you really like using VS Code and want to just live inside VS Code for that. There's an extension that tries to make that easy. If you like commands, you can use, you can use the Azure CLI. Like for a web app, you can just run this web app up, and it'll deploy the code, from the folder you're in. Or you can use the Azure Developer CLI, which is what I like to use. So all of my samples are enabled with AZD, and so that you run AZD up. So if you look on my page and look at any of these samples here, they will all be AZDified, or you can see the little column here that says AZD. Oh, I need to add it to more of these because I did add AZD to pretty much everything. And then you can use AZD in order to deploy that to Azure. And here's another view of all these example repos that you can use to get started with. Here are some more resources for EDU. So if you are a teacher or a student, definitely check out all these resources that GitHub and Microsoft has. Here's a newsletter you might be interested in. And that's it. All right. So there you go, an hour and a half of all the things you might want to teach if you're teaching web development with Python, or learn if you're learning web development with Python, or just explore if you're a professional Python developer. And I know that was a lot. If there's anything you're interested in diving deeper into, once again, do check out our Reactor series that is coming up in June, and join us for whatever it is you want to dive deeper into. And you can get, let me see if is it going to let me post the link in the chat? Let's see. Otherwise, I'll put it in the YouTube description. There we go. And there you go. And you can always see my upcoming talks if you go to github.com/PrimalFox. And I always link to upcoming talks here. So this is the Postgres Conf, and the Reactor series, and then North Bay Python if you live in North Bay. Whew. All right. So that is all I had to show today. Does anyone have any questions? All right, I assume not. You can always ask questions on the video after the fact. So I hope to see you at our Reactor series. Bye, everyone.